A shopkeeper buys 100 shoes for $100. Men's shoes for $5, women's for $1, and kids for $0.25 each. So how many of each of the shoes he bought? A shopkeeper buys 100 shoes for $100. Men's shoes price is $5 for one pair, women's $1 for one pair, and kids $0.25 for one pair. So how many of each he bought? Let's solve. So we have to find how many of each type of shoe he bought. So let x equal to number of men's shoes, y equal to number of women's shoes, and z equals to number of kids' shoes. So total number of shoes will be x plus y plus z. Let this be equation 1. And total cost of the shoes will be $5 for men's shoes, and number of men's shoes are x, so 5 times x plus 1 times y plus 0.25 times z equals to 100. Let this be equation 2. Now we have two equations. Now here we have decimal. Let's first remove the decimal. So we have 5x plus y plus 0.25 equals to 100. If we multiply both the sides by 4, then we can write 4 times 5x plus y plus 0.25 equals to 4 times 100, or it is 20x plus 4y equals to 0.25 times 4 equals to 100, and then decimal after 2 digits, so it will be 1.00 or simply 1. So we can write it plus z equals to 400. Let this be equation 3. Now subtract 1 from 3. So equation 1 is x plus y plus z, and equation 3 is 20x plus 4y plus z. So 20x plus 4y plus z minus x plus y plus z equals to 400 minus 100, because we will subtract both left hand side and right hand side. So this is 20x plus 4y plus z minus x minus y minus z equals to 300. We remove plus minus z. 20x minus x is 19x plus 4y minus y is 3y. So 19x plus 3y equals to 300. Now we have to solve for integer solutions, because the number of shoes cannot be in decimals. So we have to try the value for x and y so that we can get an integer solution. Let's try with smaller numbers. Let's take x equals to 2. And if we take x equals to 2, then it is 19 times 2, 38. So 38 plus 3y equals to 300. 3y equals to 300 minus 38, or y equals to 262 upon 3. Not an integer solution. If we take x equals to 3, then 19 times 3 plus 3y equals to 300, or 3y equals to 300 minus 57, or we get y equals to 243 by 3. Then we get y equals to 81, but this is such a big number. If y itself is 81, then men's shoes and kid shoes cannot come within $100. So x equals to 3 is also not possible. So we can see here that smaller values for x will not satisfy our requirement. So let's try taking bigger numbers. So let's take a 2-digit number. Let's start with x equals to 11, because x equals to 10 won't satisfy the integer solution, because it will be 190. 3y equals to 300 minus 190, 110 upon 3. If we take x equals to 11, then 19 times 11 plus 3y equals to 300. So 209 plus 3y equals to 300. Again, this will not give us an integer solution. Let's try x equals to 15. Then 19 times 15 plus 3y equals to 300, or 3y equals to 19 times 15 is 285, or y equals to 285 upon 3, or 3y equals to 300 minus 285, or y equals to 15 upon 3 equals to y equals to 5. So we get y equals to 5. Now let's plug this solution. If y equals to 5, if x equals to 15, y equals to 5, and if we plug this into equation 1, then 15 plus 5 plus z equals to 100, or z equals to 100 minus 20 equals to 80. Now let's check the cost. So $5 was the cost for men's shoes, and men's shoes here is x 15, so 5 times 15, plus women's shoes price was $1 and it is equal to 5. Number of women's shoes is 5, so 1 times 5, then plus price for kids shoes was $0.25, and children's shoes are total 80, and this should be equal to $100. So 15 times 5 is 75, plus 5 plus 20. 75 plus 5 is 80, plus 20 is 100. LHS equals to RHS. Therefore, 15 men's shoes, 5 women's shoes, and 80 kids shoes. So this is our answer. How did you solve it? Let me know in the comment section. Thanks for watching.